Welcome to CrystalDiffract 7. In this tutorial, we'll explore the new document window interface. A CrystalDiffract document window represents a self-contained virtual diffraction experiment. You can load multiple patterns, observed and simulated, create mixtures, stacks, toggle visibilities, and edit display and simulation parameters. In order to do all this, we've split the window into three main parts. From left to right, we have the sidebar. This is where individual patterns are plotted. We then have a central split view. This is where patterns are plotted and their reflections or peaks are listed. And on the right-hand side, we have an inspector, which lets you display notes and edit display, simulation, and refinement parameters. As you would expect, the window also has a toolbar at the top, and this is customizable. We simply right-click and choose Customize Toolbar, and then we can drag tools in or out of the toolbar to customize. Looking at the sidebar, each pattern has an icon which identifies it as a mixture pattern, a simulated pattern, or an observed diffraction pattern. Next to the icon we have the title of the pattern, and on the right hand side is a color-coded checkbox which sets the pattern visibility, so we can toggle patterns on and off by clicking their checkboxes. You can select one or more pattern rows, Shift or Command click to select multiple rows. Notice that selection does not affect the diffraction plot, but it does allow you to set properties to rearrange, duplicate, or delete list entries. So for example, I can take this aragonite pattern and move it to the bottom of the list by clicking and dragging. And if I right click, then there are options to duplicate or delete or edit the pattern. At the bottom of the sidebar, beneath this patterns list, are buttons for adding new patterns and an actions button for selected patterns. Now this lets you duplicate, edit colors, and if you have Crystal Maker installed, you can visualize their crystal structures. Use the sidebar button at the top of the window toolbar to toggle the visibility of the sidebar. Now, if you're short on space, you can keep the sidebar hidden. And when you need it, simply move the mouse to the left of the window and it'll slide out over the diffraction pane. To hide it again, move the mouse out. Mac users will feel a slight vibration in their trackpad. This is haptic feedback. It tells you that you've passed the trigger point to open the sidebar. Let's look at the diffraction pane now, which is in the center between the sidebar and the inspector. We'll hide the inspector for the moment because we're not looking at that. Now you can use multi-touch gestures to scroll and scale. So we can use a magnify gesture, pinch or magnify, and we can scroll up and down to change the scale. Now to scroll horizontally, you'll notice that we have a scroller bar that appears at the top. And we can click and drag the scroller thumb to quickly move through the entire pattern. There's a preview of the pattern faded out in the background of the scroller. And the little buckle section that you drag shows an open window into the visible diffraction portion. And you can expand that open window, that range of displayed data, by clicking one edge of the buckle and expanding or contracting that view. Now for precise range control, we can use the set range command that's available on the view range submenu. And we can type an explicit range, so let's go from 23 to 28 degrees. CrystalDiffract provides various screen overlays to help with measuring or sampling your graphics. The first overlay you'll meet are the peak tips, and these appear when you hover over a diffraction, a simulated diffraction peak. And the peak tips can be expanded to give information about the position of the peak and its intensity, its multiplicity and peak width. The screen cursor can be dragged horizontally and shows the X position, the despacing, and where it's over a simulated peak, the intensity values of any peaks. The ruler lets you measure distances between peaks by clicking and dragging its vertical cursors. And you can take that range and you can zoom if necessary. There's also the option to clear a range of points. This applies to observed data sets and is useful for clearing impurity peaks. The loop allows you to magnify an area of the plot. And this is useful when working with a small screen, as it allows you to look at areas at high resolution without having to resize. You can set the magnification in the loop using its drop-down menu. Now, unlike earlier versions of the software, CrystalDiffract now includes 3 modal screen tools. These allow you to scroll the plot by clicking and dragging horizontally, or to scale the plot by clicking and dragging vertically. We also have a magnify tool. Now, as you'd expect, this magnifies by clicking, or you shift click to zoom out. There's also a neat new feature with the magnify tool whereby you can click and drag to define a zoom rectangle, and when you release the mouse, the zoom rectangle fills the display area. The third tool is the info tool. Now with this active, you can move the mouse over the plot and you'll get an overlay, a bit like the cursor tool. Click and the cursor tool itself will appear, so that can be dragged and it gives you information on all of the visible diffraction patterns that lie under the cursor. If you click and drag, or with the info tool, you get the ruler, and that's a neat way of measuring distances. You also have the option of displaying a title and a legend. And finally, we can click and drag to copy our graphics into another program, or we can use the File Export Graphics command to output graphics at different sizes and resolutions. The reflections list is typically shown below the diffraction pane, and if a pattern is selected, contains all reflections or peak positions. You can sort the list by its column headers, and you can double click a list row to have its corresponding reflection or peak position highlighted in the plot. Now, when working with a simulated pattern, you can use the search field to find a reflection. So for example, I can type 112, hit return, and the 112 peak is shown centered on the screen. Now, if working with an observed diffraction pattern, its peak positions will be automatically measured and displayed in the list. Now, in these cases, it's sometimes useful to make the list vertical rather than horizontal, And we can do that by clicking the Rotate List button in the Reflections List header. And we get a vertical layout. And we can resize this if required. Again, we can double click on any peak to show its corresponding position in the plot. And we can customize how many peaks are shown by using the search icon in the top right hand corner of the list. We also provide the option of Phase ID, and this is accessed by clicking the Phase ID segment in the center of the header bar, whereupon the program will use its built-in diffraction database to find the closest match for your observed diffraction pattern. And here we have a null seam. On the right-hand side of the window, we can show an inspector. This appears in one of two modes. First mode is the Notes Inspector, where you can add details about your virtual experiment. Use the Edit Text submenu or a contextual menu to change fonts and colors. Now the second inspector mode is called the Parameters Inspector, and we can get to that from the Parameters segment in the toolbar. And this has three tabbed panes that let you control the display of any of your patterns, simulation, and if necessary, Rietveld structure refinement. Now the Parameters Inspector is really your mission control for setting all aspects of pattern display. For example, we can set background color, display of grid lines, position and scale for selected patterns, peak labels, and the plot colors and styles for any selected patterns. You can also set styles for text. We can display a plot title and a legend and adjust their attributes. Now the Simulation Inspector comes into its own when working with simulated patterns. This allows us to set all the details of our virtual diffraction experiment, our simulation options. It lets us edit sample settings as well, including particle size and strain values, just by clicking and dragging the sliders, preferred orientation, and we can edit unit cell parameters in real time. This allows us to simulate the effect of displacive phase transitions and observe the peak splittings. We could also look at the effect of chemical site occupancy. We can adjust site occupancies and we can add new elements to a particular site. And see how that changes the peak intensities. We can hide the inspector using its toolbar button. Just click the active segment and the toolbar will disappear. There are a couple of other windows that you'll meet when using CrystalDiffract. You will already have met the gallery window, which allows you to access the example files, your recently opened files, video tutorials, the self-guided tutorial, documentation and support. One window which you probably won't need to use very often is the program's output log, and this includes diagnostic and error information. It's particularly useful if you want to get insights into the Rietveld refinement process. So that's the CrystalDiffract 7 user interface. we've tried to make it easy, elegant and intuitive to use, and we hope you enjoy using the program.